All right, so we are live. Welcome back, everybody. Welcome back to Woodland Pools and to another Cardano Q&A live stream. So today, what I wanted to do is do things a little bit differently from how we normally do. Normally, on either Sundays or Mondays, we get together and we go through all of the news for the week and just kind of do any updates on any big news or events that have come out. But today, what I want to take a look at is with how well the book ITO has been going and how many people have participated in this ITO process. What we have seen, what we've been getting is a lot of questions of people saying, okay, well, so I bought or I swapped some book, and how do I now check to see my book balance? So I wanted to go through that, and let me make sure, can you guys hear me okay? Normally my phone here comes through in the audio, and I don't see it. Let me know if you guys can hear me all right. Let me double check to make sure this. Okay, there we go. Okay, perfect. Great. So wanted to make sure that was working. So anyway, so we had a lot of people that were asking questions about, okay, well, how can I see the details of my transaction? And even if I do have a hard time understanding it. So let me show you, for example. For the book ITO, oh, and then also, of course, for those of you that are joining live, let us know where you're joining from and any questions that you have. As I go through this thing, in between the different sections, I'll be able to answer some questions along the way. If you're watching on the replay, there will be chapters down below, so you can skip to the different sections. Yeah, so now let's take a look, for example, here at the, let's see if I enable this guy again. Yeah, I wonder why my highlight wasn't working, because I want to show you guys here. So here in the book ITO, this is what I wanted to show you guys. So here we go. All right. So for the ITO, for those that are not familiar, the way that it's going to work is that with whatever tokens you either swap or purchase, they are, when you buy them or swap them, they're going to be sent to a time-locked contract on the Cardano blockchain, and that validator will basically, the idea is that those tokens will be released on October 20th to everybody that bought them. So it's going to sit at that time lock validator until that time. So when you buy or you swap your book, it's not going to go directly to your wallet right away. It's going to be held at that address. And then on October 20th, it will be released to you at the address that you purchased it from. So what you can do is if you come here to, let me actually close this and let me hide this so you guys can see better. There we go. If you come to book.io and then click on the token sale page, down here at the bottom, you can connect your wallet or paste in an address. We just added this today. And you can see the tokens that are locked for you at the lock address. So for example, I'm going to come here. This, by the way, address that I'm looking at here is the time lock contract. We can see in the assets tab here, there are 855 million book tokens sitting at the time lock contract that will be unlocked on October 20th, okay? And so if I come to the list of the transactions, let me just grab a random one here. Let's grab the first one in the list here. So this address, all right, this one ends here in 6 RPV. If I come here and I paste in this address and click on check address, I can see here the transactions that were done and how many tokens they have locked at the time lock validator. So we were getting some questions, however, that were saying, okay, well, that's great that I can see that, but if I come and I click on this transaction, what does any of this mean, right? I mean, you have like, I thought that I just wanted to see, okay, I should imagine that I should see something simple that just says, okay, here's some ADA, here's some book, and it's now sitting at that address. But instead, you've got 1, 2, 3, 4, 5, 6 different entries. And so a lot of people were getting confused on what this meant. And so I thought, okay, let's take a look at breaking down, understanding how a transaction works. But then I thought, okay, well, to do that, we'll need to look at these UTxOs, and we'll have to look at what is a UTxO and how do UTxOs work. And then in that, we'll see that we have like some inline datum information, which is actually really important. I was like, okay, so I have to explain how datums work. And then for that, I thought, okay, well, we need to probably explain how hashing works. So I thought today would be a good opportunity for us to take a step all the way back and go through some fundamentals of the Cardano blockchain and how transactions work that I've been meaning to go through for a while, that I think will be a really good opportunity for us to talk through what is hashing and how it's used all over the blockchain. What is a UTxO? What is a datum that sits at the UTxO? And then from there, bringing it all together, how can you inspect a transaction and understanding all of those things? How can you have a better, clearer idea of how these transactions work, and whenever you're looking at something in either Cexplorer or Cardanoscan, how you can have a better idea of what you're actually looking at, okay? So we're gonna get a little bit technical today, but it's actually I think pretty approachable and really not that hard if you kind of like build on it incrementally like that. So let's go ahead and get started with that. So hello, Mark Byers, always coming in from Sydney. Happy Tuesday morning, man. So glad to have you join us. Thanks for the feedback on the audio. I appreciate that. All right, so let's go ahead and jump in. I'm actually going to hide this because I want to make sure that we can see the whole page. So let's start with what is a hash, okay? So a hash is the process of transforming any given key or string of characters into another value. This usually represents a shorter fixed length value. This is important, and it makes it easier to find the original string. So the important thing here is two big takeaways. You can take a string or an input of an arbitrary length, and then a hash will give you a fixed length output every time, no matter the input. And then the other piece that they don't mention here that's really important is that it's also deterministic. So the same inputs will always give you the same outputs. So for example, here is a site that lets us take any kind of input, and it will do what's called a Blake 2B 512 hash. So for those of you that know a lot of low-level stuff in Cardano, this is not the same kind of hash that we do in Cardano. We'll look at this in a second. Cardano does do Blake 2B hashes, but they do not 512, but that's not important. The point is, let's take a random string. We'll just type in like hello, right? And if I process this, we'll see that we get this output is significantly longer than what I put in here. And if I actually copy this and come to a character counter and paste it, we see it's exactly 128 characters, okay? Now, let's say if I type in hello world and I process that. We see again that we have a totally different hash. And if I paste that in, it's also 128 characters. So the length of this doesn't matter. It's always going to be, in this case, 128 character hash output. You can take something that's really long even. So for example, a lot of people are familiar with lorem ipsum. I like lorem ipsum is a Rick and Morty themed lorem ipsum page. You can kind of have it generate paragraphs for you of quoting things from Rick and Morty. So I'm going to take this long 4-paragraph thing from lorem ipsum, and I'll paste it into here. And then when I process this, we see even with this long several paragraph thing, we still have something that's exactly 128 characters. And now here's the other thing. So now we know that we can take an input of an arbitrary length, and then when we put it through this hash function, it will always be the same length every time, which is great because that way when you're doing something like a blockchain, you know, okay, I'm going to reserve exactly this much space for a hash of a given thing. The other piece that we said that was really important is that it is deterministic. So for example, we see here at the end, it says, okay, it makes you sound like a boob, right? So then now, if I change anything at all, even take off one period at the end here, we'll see here's our hash that we had before. And if I process this, actually, let me do this. Let's take a step back. Let's add the period back. And let's look at the hash that we got, okay? So we're going to copy this hash. And if I do a find, we see that here it is, right? It finds it, okay? So now let's take this period off. And let's process this again. We see it's a completely different hash just because we changed one character in it. And now again, since it's deterministic, if I add this period back, I should have the exact same hash that I did before. So if I process this, I now see that it matches exactly to the hash that we were looking at before. Okay? So this is kind of cool. The fact that we can take inputs of arbitrary lengths and that we get a string of a fixed length that is deterministically the same every time gives us a few cool things that we can do. The first one is that, let me think of like best way to, so the first one we can take a look at is, for example, this is the way that your addresses for your wallets are generated. So for example, you know how we've talked about in the channel a lot that when you have, where did my ledger go? When you have like a ledger or any kind of wallet, how on it you have a public key and a private key. So that private key, right, the public key, what you can do is, if you take the hash of that public key, here, for example, this is the ASPEN documentation. We talk about ASPEN on the channel all the time. It's one of my favorite projects to help people develop smart contracts. All of the on-chain validators that we wrote for Book were written using ASPEN. Now we can see here, for example, there's a function in ASPEN that if we take a Blake 2B hash, similar to the one we were looking at, there's a 512 hash, but this ASPEN one is, the ones we use in Cardano is a Blake 2B 224 hash. Again, the details don't matter. But if you take the Blake 2B hash of the public key or the verification key, using that, you can derive an address for a wallet. So the cool thing here is that to understand that when you have your public and your private key, the hash of your public key, that pub key hash, you might have heard that term before, the pub key hash or the verification key hash, that is deterministically exactly how your address is created for your wallet. That's how, for example, when you make a new wallet, you have all of your addresses for that wallet are already shown to you before any funds are in them, because they're all derived deterministically from a hash of the public keys for that wallet. So that's one cool thing. The other cool thing is that if you look at, for example, NFTs sitting in your wallet, right? Let's say, for example, this Woodland Pools NFT that I made. We can see that for this one, when I look at the metadata of my Woodland Pools NFT, we can see that the source starts with IPFS and then has this random string of characters. What's interesting about this is that if you think about like a website, if you like inspect an element on a website, well, actually, okay, yeah, let's do this. Let's do this live and see how this works. So if we come here, for example, let me open up the element inspector. Let me turn this off here. And if I come and look at, for example, the source, well, let's do something better. Let's do something that has an actual image in it. So let's look at this like Rick and Morty thing here. Or how about this with a character counter? Is that text? I don't know. Let's find out. So if we come here and we look at this here, is this going to be an image? No, of course it's text. I want to find something that has an image on here that we can use. Here, this will be fine. Let's do this in the book.io page. All right. So if I open this up and I look at the source of this here, I can see that that image is coming from here, from CDN, Book.io app, right? This is like a regular web address, right? Like what we would expect to see on anything on the web, where it's just some address and then something that comes after it, right? As we all know that, however, like on the web, if for any reason this changes at all and it gets moved to somewhere else, maybe I bookmark this link, and if sometime later it gets moved, I'll come here and I'll have a broken link, right? It'll probably like look like something like this, where it's just nothing there, right? Now, the reason why we don't have this problem for IPFS with our NFTs is because, the reason why we don't have this problem with NFTs is because we use what's called IPFS. So IPFS is the Interplanetary File System. And the way that IPFS works is that for all these projects that host these NFTs, so for example, this was minted using NMaker. NMaker, when I mint this NFT of this image, what they do is they actually take the image, they take the hash of that, well, they upload it to IPFS, and when it's uploaded to IPFS, what IPFS does is it takes a hash of this image, and then the location of the image on IPFS is literally the hash of that image. So the same way how here we had our hello world, and that resulted in some hash, and it makes the same hash every time, you can also do this with arbitrary inputs. You can take an image and take the hash of an image, and then for IPFS, that hash at IPFS is the address of that image. So for example, if I were to copy this and open up a new tab and paste it in, this right here is showing me this image on IPFS, and it wasn't resolved by me typing in some www whatever. I literally just went directly to IPFS / the hash for this image. Now, the other cool thing about this and the way that hashes work is, again, because it's deterministic, this is something that we talked through last year with Patrick Tobler from NMaker when we were talking about NFTs. Let's say for some reason, NMaker stopped pinning and hosting the image for my NFT on IPFS. If I came here and I save this image and I download it, then later, if that image is no longer being pinned and hosted by NMaker, if I had this image saved and then I went to IPFS and I uploaded this image, the resulting hash of this image would be the exact same one that we had here, for the same reason that we talked about, that if it's any different at all, it's going to be a completely different hash, but if it's the same, it's deterministically the same output hash every time. So I could always then personally take my downloaded version of my image, upload it back to IPFS, and have the same exact resulting hash, and it'll resolve again, and all my images and my NFTs will render. So that's pretty cool. The last thing that's really neat about hashing on the Cardano blockchain is, so now we've talked about how you can use we can use hashes to generate addresses for our wallets using the hash of our pub key hash or verification key hash of our public key can generate addresses for us. Hashes of images that we use uploaded to IPFS can generate IPFS addresses for us to host images. But then the other thing that's really cool is that when we look at transactions, and we're going to talk about here transactions in UTxOs in a second, but when we look at, for example, this transaction that we were talking about, right? Something to note is that this transaction, for example, when you're looking at this transaction detail, if you think about how many times, for example, you've passed around like a transaction, someone says, okay, here's the transaction ID, or when you're going through like a history of transactions on your wallet, or even here, you see here like here's the transaction, and you click on it, right? This is not just a random ID. This transaction actually is, if you look at it here, is actually a transaction hash. This is a hash of all of your inputs and outputs. So it's actually, to a certain degree, this is not exactly how it's done, but to a certain degree, what we're looking at here is we have basically these inputs that went into that transaction, and then these outputs that went into the transaction, and then running it through the specific hashing algorithm that the Cardano blockchain uses, the resulting hash that's generated, this is exactly how, more or less, is exactly how this transaction hash for this transaction is generated. So the cool thing about that is that if you think about that, just knowing the inputs that you're going to have and the outputs that you're going to have, if you think about how we did this didn't involve the Cardano blockchain at all, right? If we had in hand the same hashing algorithm that Cardano uses, which you can do offline, then what you can do is that you can take the inputs and the outputs and then get a transaction hash. And then from these outputs, you can then use those outputs to make another transaction and then get a hash of that, and then another transaction and a hash of that. And then once you know all of these different transaction hashes and all of them dependent on each other, this is the basis of how transaction chaining works. And the reason why we can do transaction chaining offline is because of knowing and being able to calculate the hashes of all of these things ahead of time. So that's pretty cool. Yeah, okay. So I'll take a pause there and get some water. So that is the basics of hashes. Let's say hello to Mark Byers and what is up, Book Fam? Hello, Mark Walker. All right, so let's continue on. So now that we know that, we understand how hashes work, that it takes an arbitrary input and gives us a fixed length input string. It is deterministic, so the same inputs will be the same outputs always. Knowing all of that, we can take a look then at UTxOs. And what is a UTxO? Like when we're looking at this, these are UTxOs. You've probably heard this before, but what is a UTxO? And so before I do that, I want to make sure, because a lot of times I forget to do this, I want to stop and say a huge thank you and welcome to all of our newest delegators. We really appreciate your support, and it's, like I said, always, it's a thrill to be on this journey with you. Sorry, I'm kind of distracted today because there's so much going on digging into this low-level stuff, but thank you so much for joining us. We're so happy to have you with us. Let's keep growing together. It's an absolute blast to see the pool continue growing and to be doing this kind of stuff. And actually with that, let me say, if you appreciate the work that we do here and this kind of stuff that we dig into, sometimes high-level news, sometimes low-level, really nerdy stuff on how this all works, the best way you can support the channel is by delegating to the ASPEN stake pool. So with that, let's take a look at UTxOs. So let's take a look at UTxOs and what they mean. So a UTxO is just what it means is an unspent transaction output. So if we look at a transaction, right? When a transaction is generated, you have some inputs and you have some outputs. So these outputs here, right? These are outputs that can be used later on. And so really, it's a very simple way to think about it is, take this off here. Really simple way to think about it is that you've got a transaction and it makes some number of outputs, right? Like these guys here, all right? And then when those outputs are generated, these are now spendable outputs, right? Let's draw our little lines here. Cool. So this transaction, let's just say, generated these 3 outputs. Now, these outputs are available to be spent, but they are not spent yet. And so by definition, they are unspent outputs from the transaction. They are unspent transaction outputs. That's all that UTxO means, okay? So let's talk about some basics of how UTxOs work. All right, so let's pretend that this is sort of like the first transaction ever in time at like the beginning of time, right? Let me move this over to here. Perfect. So let's pretend, so like we said, all transactions have inputs and outputs, but we'll get to that in a second. Let's just pretend, for example, for a second here, that this is the first transaction ever at like the Genesis block, and that we've got just this transaction making a single output with no inputs. Pretend this is the very, very beginning of the Cardano blockchain. So let's say, for our example, who we got with us today. Let's say this is Mark's wallet, okay? So this is Mark, all right? So let's say Mark has gotten, at the very beginning of time, has gotten 100 ADA. All right? Now, this is the UTxO of 100 ADA sitting in Mark's wallet. But now, let's pretend that Mark wants to then make a new transaction. And what he wants to do, I saw Artificial was with us a little bit earlier today. I saw, Artificial was with us earlier today. So let's say that Mark wanted to send Artificial 25 ADA. Okay? Let's do that. Cool. And this is going to go to, oh, come on, my mouse is not wanting to work now. Oh, there we go. Cool. He's going to want to send this to Art. So now, Mark wants to send 25 ADA to Artificial. Now, here's an important thing about how UTxOs work. It's different than account-based models like an Ethereum. And the thing is, an account-based model like an Ethereum, what you would do is you'd say, okay, you take Mark's total of 100 ADA, just subtract 25, and then that is how much now Artificial has. The problem with this is that this relies on what's called global state, where you need to know everybody's balances all at once to know anybody else's. The cool thing about UTxOs is that it makes it so that it feels a little bit more confusing sometimes, as we kind of have to like learn some of this stuff together. But the cool thing though is that with UTxOs, you don't need to know anybody else's balance to know exactly how much you're holding. And so think of it this way. If Mark has this 100 ADA and he wants to send Artificial 25, what will happen is this 100 ADA UTxO, he can't just only send 25 out of the 100. The way that UTxOs work is that whenever a UTxO is part of a transaction, it is consumed and gone forever. And then new UTxOs are generated. And what we see is that we've got the UTxO for the 25 ADA that is sent to Artificial. And then the 75 ADA that's left over, that is sent back to Mark as change in a brand new UTxO. So this one is consumed, and then two new UTxOs are made. This one for 75 ADA, and this one for 25 sent to Artificial. Now this is actually really beneficial because if in the future, if Mark ever wants to construct some transactions, he doesn't need to know anymore about Artificial ever again if he doesn't want to. He just needs to look at his own wallet and just know that he has 75 ADA, and that's it. You can look at just how many different UTxOs you have and add them all up, and that's all you need to worry about. So, yeah, this is how this works. And then the other piece too is that these are not just, again, arbitrary random things, right? What we talked about before with the transaction hashes, this transaction now, when we want to identify it, kind of like we talked about before, right? We can take Mark's input of 100 ADA, and then we can take the output of the change address that he's sending to himself, and then the 25 ADA that was going to be sent to Artificial, and then the hash of these inputs and outputs is what's going to make the transaction hash that identifies this transaction. So this transaction will actually be called this, right? I mean, again, this is a slightly different hashing algorithm, but this is exactly how it's going to work on the Cardano blockchain. And now these UTxOs, the way that they're identified, they're also not just arbitrary. These UTxOs now will be also identified by the transaction hash. And then what will happen with these is that they will be the transaction hash and the index that they're sitting in, or they came out from in that transaction. So this would be the transaction hash index 0, and this one would be index 1. So for example, when we were like looking at a transaction like this one, these two inputs here generate these 4 UTxO outputs, and then this transaction hash is what's generated by hashing the inputs and outputs together. And these 4 UTxOs, their actual names, you can look them up on chain, is this hash and then index 0, 1, 2, and 3. So similarly, here we see Mark's change UTxO is the hash index 0, and then Art's is index 1. Okay? Cool. So that is how, that's the basics of UTxOs. And so again, a UTxO can never be partially spent. It's always fully consumed. And then anytime you need to make change, you then take what is left. And that is how you take what's left, send yourself the change, and then you send the balance of the other one to somebody else. So now, we're almost all the way there in terms of understanding UTxOs. The last piece that goes into a UTxO, it's important to understand, like what we see here, right? This says inline datum. The last thing that you can do in a UTxO is include some information or some data that is called the datum, okay? This datum can just be some information. It can be any kind of information that you want, and it does not have to be included, okay? But the reason why this is useful is because on-chain validators and smart contracts use this information for all different kinds of reasons. So now we're getting really close to being able to understand how to look at our transactions for our book transactions or for anything else. If we think about the way that the validator is going to work for our purchase or our swap of book, if you think about it, you went in and you, like for this person, we pasted in their address. They spent some amount of ADA. They're going to get about 15,000 book at some point, but for now, it's sitting and locked at the lock validator on chain. So the question then is, all right, well, but then how does the validator know what address to send it back to in the future? If there's just some amount of UTxOs sitting at that address, then how does it know who to send it back to? And the way that we do that is with the datum. And so what's included in the datum when it's sent to the lock validator is going to actually be the pub key hash of the address of the person that purchased it. And the cool thing about that is the wallet person that purchased it. And the cool thing is, as we saw before, with that pub key hash, again, the hash of the public key of that wallet, we saw here that having the hash of that public key or verification key, we can then get the address for that person on chain. And so then the cool thing is that then in the future, when it comes time to unlock that UTxO that's sitting at the lock contract, the validator will enforce that it has to go to the address that corresponds to the pub key hash that was put in the datum for that person. So let's take a look at that. If we come and we look at this transaction, for example, we can see here in this inline datum, if we click on it, we can see here, actually see the information in the datum. And these bytes right here, this is literally the hash of the public key of this person's address that we were looking at, of this person's address as this transaction. The hash of their public key is this right here. So in the future, when it comes time to unlock this UTxO and send it to somebody, the chain is going to enforce that it has to be to the address that is derived from the verification key or the pub key that is hashed right here. Okay? So that's sort of how it all comes together in terms of what UTxOs are, how they work with hashing for transaction hashes and stuff like that, and then the datums and the stuff that can be put together. So with all of that, let me actually stop and take some water. Let's see if we have any questions. As a citizen of the USA, all I can do is purchase and sell books. I have no ability to get involved in the book token. Yeah, so in the United States, there is a limit on participating in ITOs. And so when you come to the page here, you have to declare the country that you're from. And if you're a part of the United States, it'll tell you like, hey, you can't participate. Yeah, so you'll need to, and if you want to do that, you can buy it on the secondary market after October 20th. But yeah, it comes full circle. Okay, cool. Yeah, Artificial. Thanks for sticking with me. I know it was a bit of a long walk there, but this is why I thought it was so important for us to start at the very beginning with, let's pick. Yeah, I just want the error to go away. So this is why I thought it was so important to start at the very beginning and look at what a hash is and then sort of build up from there, because it's all completely interrelated. The use of hashes in the Cardano blockchain is everywhere. You'll see this everywhere. It's the way actually that we preserve the size of things on chain. Is instead of the cool thing, I guess is a good takeaway. The cool thing about hashes being deterministic and always being the same inputs lead to the same outputs is you can do really cool things on chain where you can like prove ownership of a thing without having to publish the whole thing on chain. So for example, let's say like Artificial had written a book, okay? And let's say like the book was like all of this text just to say something, okay? What you could do, for example, like remember like you probably back in the day, you remember like the poor man's copyright where like you would write a book and you would like put it in an envelope and mail it to yourself so that way the postal stamp on it for that date would show that you'd written it like on that date. You could do something similar on the blockchain where you could take an entire novel worth of text. You could then hash that novel worth of text. And then what you could do is on chain, you could store the hash, only the hash of 128 characters right, of your whole novel, like be thousands of pages long, you could store just the hash of it. That's 128 characters long. And then in the future, if you ever want to prove that you're the one that wrote that book on some date, you could then show anybody in a court of law or whatever, you could say, okay, let's take my whole book, let's run it through this hashing algorithm, and then when the output hash comes out, it's going to be, because it's deterministic, the exact same output. So then you could show on chain where it was way back in time that that hash was published, and show like, yeah, no, I wrote this book 2, 3, 5, 10 years ago, because there is no other way that this hash could be generated if it wasn't for the exact same inputs. So with hashes, you can do really cool stuff like that. And so I thought it was important to kind of build up to that point and know how we got there. So now that we are there, though, let's take a look at how we can understand how this all comes together and understand our transactions when we're looking at this stuff as part of either the book ITO or really any transactions that you look at in your wallet. But let's look at the book ITO as the example that we'll work through here. And let's sort of think through what this is going to look like. Let's say, so art. Let's say that Artificial, okay? Let's say Art wanted to buy some book tokens, okay? So let's think about what we're gonna expect to see when we look at this transaction detail here, okay? Because we know that Art is going to use some ADA to purchase some book, let's see. So basically, there's a broad version of metadata return. Yes, but it's even more than that, because metadata was sort of like added on after the fact. The hash of something is actually like fundamentally like a fundamental thing that's used all across the blockchain. It's like a really, really huge thing. But yes, like it can be used for almost anything. We use it for all kinds of stuff. I mean, again, you use it for the address for your IPFS thing. It's the way that your addresses are derived. It's the way that like any kind of like data that's stored on chain is verified. Yeah. But anyway, okay. So let's take a look at what we're expecting to see for our transactions here. So the first thing is we know that Art wants to spend some amount of ADA to get some amount of book, all right? So let's think about what's involved in this process. We know that we're going to have Art's wallet that has some ADA that's being spent. We also know that we're going to have the book.io wallet that's going to have some amount of book that needs to be presented into this transaction. And then if we think about on the outputs, let me actually hide this here. On the outputs, we know that let's say Art only wants to spend, I don't know, 25 ADA or something, right? We know that if Art is going to be spending 25 ADA, she's going to need to get some change back, right? We also know that the 25 ADA that she did spend is going to need to go, let's call this the book.io commercial wallet. Okay, and let's call this one, let's call it the book.io book wallet. How about that, for lack of a better term? Then we know that similarly, not all of the book sitting at the book.io book address is going to be spent. So some change is going to come back here, the same way how Art got her change. And then finally, we know that the ADA that she did spend, the 25 ADA, So she got her 75 ADA change. The 25 ADA that was spent is going to go to the book.io commercial wallet. Some amount of book change is going to go back to the original wallet. And then finally, we know, as we talked about here, system unlocks on October 20th. Finally, we know that the lock validator is going to get whatever book it was that she purchased. Let's say that her 25 ADA, actually we could do some real numbers here. Let's say, okay, it's less than the minimum, but let's say, so 25 ADA is going to buy 690 book. So let's just do like the numbers that the page would present us with here. So she's going to buy 690 book. Let's say there was originally 1,000 book here. And so then we should expect to see 310 book left going back in change. So here's what we should expect to see if we look at our transaction on chain, okay? We should expect that the UTxO for the input amount from Art should be consumed. The UTxO for the book.io book wallet that has the total amount in that UTxO should be consumed. And then we should expect that on outputs, Art should get her change for the amount that she didn't spend. The book.io commercial wallet should get the ADA that she did spend. the lock validator should get the book that she's going to get, and it's going to hold it for her until October 20th. And then the book.io book wallet should get its change of the book that was left that didn't get spent. Okay? Does that make sense to everybody? Hopefully that's clear. So now let's go ahead and actually look at that, and we can see how that actually comes together. If we look at this transaction, the one that we had pulled up here on the book.io page, which we do it again just to show that this is like, for those just joining us, to show this is not like magic. I came here to the book.io lock address. Wait, no, this is not it. Actually, I have it right here, don't I? Yep, here's the lock validator. Let's do this from the very beginning. So here's the lock validator. Let's refresh this page. Here's a lock validator address. It's currently holding 855 million new book tokens. Let's go ahead and grab a random transaction from here. I'll grab this top one here. This transaction hash. And actually, you know, we don't need to do that. Actually, yeah, it's fine. Let's open up this transaction hash. And then what we can do is let's grab the sending address, which is this person. Okay. We come to the book.io page. Let's check that address to see how much book they have. Here is the transaction for that book. So here we go. Now we are looking to see the book that this address purchased in this transaction. And with what we were just talking about here, we can see how this exact thing plays out right here. We can see our purchasing address started with a UTxO that had, this might be a little tiny. Let me see if I can make this bigger. Okay, cool. Yeah, perfect. We can see that our purchasing address started with a UTxO that had 1500 ADA in it. And we can see that the book.io book wallet had a UTxO with 200,000 book in it. All right. Now, these are our inputs. That is these two. Now, on our output side, we can see, let's look at the change first, just that way we look at them, identify them, and then we can kind of ignore them after that. So if we look at the same address here, let's find the same address. Here it is right here. We can see that of the 1,500, they got back about 50 ADA. So I would expect then that they spent about 1,450. And we can see then for the book.io book address, here it is right here, of the 200,000, they got back about 160,000. So we should expect that roughly about 40,000 was actually spent. So we can ignore this one and we can ignore this one. And sure enough, if we look, we can see that, sorry, yeah, they got 50 back, so they spent 1,450. Sorry, I said that backwards. So this address, if you look at the same address here, they got 50 ADA back of the 1,500, so they spent 1,450 ADA. And sure enough, if we look, this address here got back 50 ADA, and then if we look at the ADA that was sent to the book.io commercial address, here it is right here, 1,450 ADA was sent to the book.io commercial address. And similarly, here's the change that went back to the book.io book address, but here, this right here, this 41,000 book is what was sent to the book lock address. And I know this is a book lock address, and we can verify this because, again, if we look at this address detail and we look at the assets, here's how we started this whole thing. There's the 855 million book being held at this address, of which 41,000 is the book that this person just bought. It is now sitting at the book address waiting to be unlocked on October 20th. And then once again, to bring it full circle, how we saw before, how do we know who to send this back to when it's time to unlock this? We see here there's an inline datum in the UTxO that was sent to the book address. And if I click on this inline datum, I see that the data inside of it is this right here is a hash of the public key of this address that we were looking at, of this person. If you were to take their public key and you were to hash it, it would be exactly this. And then using something like this in Aiken, if you take the public key hash from there, you can derive the address. And so on chain, we'll be able to then derive this address again. And then when it needs to be sent back to that person, that's exactly how we know who to send it back to. Cool. So that's a great way that you can understand if you want to look deeply at the UTxOs. But sometimes you're like, okay, that's cool, but I don't necessarily want to look at all of that detail. And so one other thing that I wanted to show you guys that's pretty cool is if you get a transaction hash, Cexplorer we use because it loads up the transactions really, really quickly. and you can see by default the UTxOs. But if you want to just see a summary, you can come to Cardanoscan, and if you paste in a transaction hash on Cardanoscan, you can see the same level of detail, all the different UTxOs. But additionally, what they have, which is a lot cleaner, is also just a high-level summary of the whole thing. So when we looked here, for example, we said, okay, here's the change that came back, but the resulting thing was 1450 was spent and sent to the book.io commercial address, and 41,000 book was sent to the lock address. And if we look at this summary here, we can see that the 1400 ADA was spent by that person, the 41,000 book was spent by the book commercial or the book.io address, and here received to the lock address is that 41,000 book, and received to the book.io commercial wallet is that 1400 ADA. So sometimes this is a little bit cleaner to view as a high-level summary. So I'll share this below as well. Okay, so that was a lot. But cool, I wanted to make sure that we went through that so everybody kind of understood how all of that comes together. So let's go back. Last thing, like I said, this is for a nice simple transaction, but for all of them, even the more complex ones, they all work the exact same way. So let's come back to our lock address, and let's look at some recent transactions. And I want to just show you how you can do this for any number of UTxOs, no matter how complicated. So this is actually a good one. So we can see here, like, this looks really intimidating when you first come up to it, but you'll see how it's all just the same thing as always. That it's always the same idea. So in this case, we have this address. Here are the inputs on the left, outputs on the right. Here's this address. They have 1850 ADA, and then all of these native assets sitting here as well. Here is a book UTxO with 200,000 book in it, right? Let's look at the outputs here. If we look, we see this same address. Now, we would expect that this address is just spending some amount of ADA and getting some book locked on their behalf. We can see here that this same address is getting all of their assets back, which makes sense because this shouldn't be involved in the smart contract at all. So they're going to get back, as part of their change, all their assets back. And then we see here is the 700 ADA that they spent that gets sent to the book.io commercial address. And then here is the book that is sent on their behalf. The roughly 20,000 books sent on their behalf to the lock address with the inline datum of their pub key hash. And then here is the book address getting back its change. Hey, Stacy. Hi, long time. Good to see you. Cool, sweet. So I think that that's good. I wanted to just make sure that we went through that so everybody can kind of understand how to see and understand the transactions to be able to view their UTxOs. The one last example that I want to show, see if I can find, yeah, here we go, perfect. Here, this one I wanted to show as an example for those that were doing swaps a while back. I want to show an example of a swap transaction. So for this one, it's similar, but the only difference was that your book old was sent to an archive address, right? Because we're not using book old for anything anymore. So similarly, here we have this IMG address. We can see in this case, they presented 2 UTxOs to cover all of the costs and also all of these random assets. Here's the book.io book address. So we see IMG got all their assets back. None of that was involved in their smart contract at all. And we can see that when they did the swap, their book old was sent to the archive address. Their new book was sent on their behalf to the lock address. And then the change of the remaining book from the book.io address was sent back to itself. So here's this person getting their change with all their assets. Here's the book address getting their stuff back. Here is their old book being archived to never be used again. And here is their new book going to the book.io lock address. So you can see how this works now for any transaction, and hopefully that's a little bit less intimidating. All right, so cool. I just wanted to go through all of that so we all understood how all of that worked. I know that that was a lot, but the good thing is that all of this is recorded, and you can watch it back if that was a little bit too fast. But yeah, so next week is the last week of the month, so we will have Cardano 360, and we will do our normal sort of news updates, and we'll also break down Cardano 360 as well. Yeah, so thanks for everybody for joining us tonight. If you have any questions that was something that was still kind of confusing, leave a comment down below and I will answer them in the questions afterwards. If you appreciate the work that we do here, the best way you can support the channel is by delegating to the ASPEN stake pool, and we will see you guys next week at the same time at 11 p.m. UTC, 7 p.m. Eastern Time,